Hello, everyone. Thank you all for joining this session. I'm Nishant Srivastava. I'm an Android engineer working here in Berlin. And today I'll be talking about Android libraries in general, how they start up, how they initialize, and a lot of different things that comes around this whole thing, right? So what I'm going to be talking about this topic, the first thing that we need to address right now is the why does this topic even needs to be talked about, right? There's so many different things that we could actually have talked about, but this special topic, like what is this even required? Well, the answer to that is that there are many ways of initializing an Android library. Some are good, some are bad. You have some pros and cons. You can control some, you can't control some of these. Some of the new ways of doing these things are mostly chaotic. They cause a bit of a problem. And we want to actually look at those particular scenarios. And then towards the end, we'll be talking about what can be done to unify this fragmentation. To talk about all of this, let's first understand how these Android libraries initialize, right? And to walk you through all the process, we'll start from the very basics and then eventually move towards the part where things become chaotic. So the very basic way of how you would initialize an Android library is, imagine it's a normal class which has a constructor, and then it basically initializes its base value. So in our case, our library code has an entry point with a class called mylib, which takes in an argument called token string. And based on the code that you can see on the slide, what we are trying to do in this mylib class is to create an authentication or authorization header, which you will usually be passing around in a retrofit or an OKHTTP network call, right? So what it's basically doing is there's a start string called authorization colon bearer. And then what we do in the change token function is that we concatenate with a token value. So your whole string becomes authorization colon bearer and then some token value in place. And then when you want to get this value, you basically call the get auth header. That's what the library does. Most of our libraries would actually be doing the same thing throughout the session itself. So it should be clear to you like exactly what this library is doing. But the core point that we want to note here is the part that how this value, the base value, is set up. So you can see that there's a constructor which takes an argument called token string, and then there's an init block internally which calls change token with the constructor passed argument into the change token itself. So basically, as soon as you initialize instantiate the mylib class, you are also setting up a base token as a default value. When you need to call this particular class from your library into your application, this is how you do it. You basically create like a mylib variable which instantiates the mylib class. And right now we are passing a dummy value because we just want to showcase the functionality. And that 123 value is going to be concatenated with authorization colon bearer and then 123, right? And then just to showcase that, imagine that you got a refresh token. You could also change this token using the library. So there's another function called that says mylib.change token with a different dummy value 456 here. And then eventually what we are doing is that we are taking that the modified authorization header, the string value, and we are just putting it out onto the text view on the UI screen, right? So what you need to notice here though is that you have control over this. You decide when you want to instantiate mylib class, and you decide when you want to like basically do other things with this particular instance. So at this particular point in case, the library is more in our control and we could make changes. Another variation of this thing is that you could actually get rid of the constructor and the init block and replace it with the init function. So all the other things being same, the only difference here is that you now have a function init as a standard init function, and then you just pass the token, and then you do the same thing that you were doing in the init block, as in calling the change token function with the token pass. Again, if you wanted to use this, the process does not change a lot, except now when you instantiate the class, you don't pass it through the constructor, but now you have the responsibility of calling the init function. So you can see you still have the control over the library code instantiation, but you have the responsibility of calling init function also. So it's a bit tricky and like something that you as app developers might not want to do it, or maybe if you forget to use the init function, then there's going to be a bit of a problem with the process. So that's something that's very general, very simple, and most people can actually do this. It's not new stuff. Well, what's the other way of initializing? So one other way that a lot of Android libraries are actually doing this, and I'll talk about which libraries do this, is by using a lifecycle observer, right? So when you start talking about lifecycle observer, your library needs to depend on the lifecycle runtime and the Java 8 lifecycle common dependencies. Once you have those dependencies, it gives you access to default lifecycle observer. So what we are doing is that we are modifying our class mylib, which is within our library, and what we are doing is that we are extending, or we are implementing actually the default lifecycle observer. This allows us to override the on start and on stop function from the lifecycle owner. And what we can do is that we can trigger functions automatically when a certain event happens. So the rest of the class in general would have the same kind of functions like before. There's a change token function, reset function, and the get auth header like we saw earlier. But when you had to use this in the my activity, like your main activity, the way that you do is that you still instantiate the class, right? And then you reference the value in the on resume, but you also need to add observer on the lifecycle. Okay, so when you want to add the observer, what you do is that in your on create, you do lifecycle.add observer and then pass the instance of your mylib class, because it is the default lifecycle observer. And then on destroy, you remove the observer. It's pretty simple, pretty straightforward. The important point to note here is that a part of the library's code will get triggered whenever the activity goes into on start and on stop automatically. But you have the control in this case by deciding when do you add the observer and when you remove the observer. Say you remove the observer way before, not in the on destroy, but in some other instance or a particular case, then maybe the on stop would never be triggered. So you still have the control in this case, right? So this is another way of doing this. And one particular library that comes to mind, and also like I want to mention here, is that you have this functionality in Picasso. You probably didn't know, or maybe it's been around for a pretty long time, since 2018. I'm just showcasing the pull request where this was added. It is, as of now, it is also there in Picasso with the current release also, right? So this lifecycle awareness functionality just allows you to trigger parts of the library. Usually people would do that to clean up their instances, or they will do something like they want to initialize something as soon as the on start is called and not the on create. So they want to do things when the event is triggered on the lifecycle owner. And that's a easy and good thing to do. It's not bad, right? And then the other way of actually dealing with this is that you could actually have created a singleton class to initialize your library. Again, we are doing the same kind of stuff, but we have modified our code in a little bit here. And the reason we have modified this is that we want to take in a context. Most libraries actually want to reference to a context, and they want to do some sort of work from the Android ecosystem itself. In our case, what we are doing is that we are using the context to get the string value uh, with the string starting underscore string key coming from the strings.xml file, right? And this file in general has this key, which is the basic starting string authorization colon bearer. We are kind of just doing the same thing, but this time we are referencing it from the Android ecosystem and bundling our string file itself. So when you have to actually call this singleton class from your library, what you would do is that you will do mylib.init, and then you will pass the application context, right? And then if you wanted to change the token, you will say mylib.change token, change the values, get auth header, you will just get the value. But I want to highlight the init function itself. Now, what this init function is doing is that you have your mylib, and then what you are taking in the init function is the application context. You need to still call this. You have the responsibility of calling this. Otherwise, you will not get the string value right away, right? So in the initialization process, some people would say that you probably don't need to do this in the activity, and you could have created a custom application class and then just call the same thing. But as an app developer, I still have to create that custom application class. So it's a responsibility that I would have. One of the example of library doing this is probably Coil, And there are many others, but I'm just highlighting some of the famous ones. So Coil actually uses the singleton pattern to initialize its image loader class itself. And it does it pretty nicely. You can go and check out the code to figure out what else other things it can do. But the point that I made about the custom application class is something that people can do, yes, but that's an extra responsibility on the app developer again, and it doesn't simplify anything, right? So what actually started happening is that people started looking at other alternatives that they could do, initialize their library code without the intervention of app developers. You just include the dependency and it auto initializes itself. To do that, a lot of companies, or I would say like starting some small startups itself, they started experimenting with using a content provider. Now, you might all probably must have read this blog post from Firebase. This was probably the first time someone was starting to write about what using a content provider means to initialize your library. They were talking about how they initialize their Android SDK. Now, Firebase does analytic stuff, so it needs to bootstrap its SDK as soon as it can. The gist of this whole blog post was in general that what it was saying is that a content provider is created and it is initialized on the main thread before all other components. All other components being activities, services, broadcast receivers, anything else, right? And then an important point to also note is that a content provider participates in a manifest merging at build time, which is a great thing. We'll talk about why that is a good thing. And then at the end, it talks about that for app developers, it takes away the initialization step of library during integration. You don't have to write that init function at all. So what we're going to do is that we're probably going to try and do the same thing and implement it our own mylib class to start using content provider. To do that, we will use the same singleton mylib class, but we'll add a new class now. And this one will be called mylib init provider. It does this basic stuff as you would imagine. It extends from a content provider that gives us access to an on create function, which provides the context, right? So what we would do is that in our particular mylib init provider, we could just call mylib.init and then just pass the context. This will initialize the library and we are done. As an app developer, you don't have to call that specifically. An extra step that you also need to do, probably not as an app developer, but as a library developer, you need to add is to add a provider in your library's Android manifest file, right? So what you need to do is you need to add a provider component, and this is what it looks like. You have the mylib init provider, the class that we just created, which extends from content provider. And then there's a authorities string. This has to be unique. The application ID is the manifest placeholder that gets replaced during the manifest merger state and replaces it with the application ID. So this keeps the provider tag in general unique to the application. This is why the libraries are able to work with this, because a library can be in multiple applications, but still is unique to that application package. So once you do that and everything is in there, you build the project and you integrate the library, you will see inside the manifest merged, the merged manifest file. You can see that right now my project is called using content provider to init lib is the project name. And then mylib is the package name. So the manifest is coming from there, and it has merged it into the final merged manifest file. There is the name, and then you can see the authorities has the github.nishul's example, and then the package name of the app dot my library. So the replacement has also happened, and the provider is also merged into the main manifest file. When you have to use this, the best part is that because this happens automatically, a provider is already merged into the manifest file, the init function would actually be called as soon as the app starts up. A provider would be started up, onCreate will be called, and the mylib init function would be called. That means that we can get rid of this call from within the main activity. It becomes as simple as this. You basically call any functions you want. You don't need to call init function at all. Now, a lot of these the other libraries are actually using this functionality, right? So you have the process lifecycle owner, which is pretty normal. It should do that because it needs to start up, initialize itself as soon as the process start up, right? So they are doing this in the AndroidX right now, which is totally fine. And I think they are doing it for the right reasons. Then you have the work manager, which also needs to do the same thing. It needs to schedule jobs and everything. So it also does the content provider trick. Firebase Common, again, an analytics SDK. It also needs to bootstrap itself as soon as it can. So it does the same thing. It also uses the content provider. And let's be honest, like they were the first ones who wrote the blog post, so they already were using this for a very long time. Well, apparently Facebook saw this and they also started doing this. The problem with this one is that if you use any other SDK from Facebook, the Facebook core comes as a dependency. So this is happening irrespective, even if you want or if you don't want. So imagine that you installed or you added a dependency called Facebook Messenger as a dependency. Facebook core is coming with it. So this provider would anyways get merged, and it will initialize the Facebook SDK, the core SDK itself. You might see some lag in your startup just because you just added that dependency. Okay, so, well, if so many libraries are using this, is that a big problem? Well, there are a couple of problems in this case that we should look at. So the first being that libraries can auto-initialize them, even if you don't want them. The same case that I was discussing for Facebook, this is what will happen. Libraries are invoked as soon as the process starts because the content provider is invoked as soon as the process starts. And because these invocations are happening, there is a memory overhead. Okay. And when there are multiple providers merged into the manifest, there is no defined way that you can tell at what order the initialization needs to happen, right? You can't actually control that. So what you also need to make sure is that we know that content providers runs on the main thread, so the initialization is also happening on the main thread. That leads to an increased startup time of the app. The UX gets sluggish. And let's be honest, we are abusing the functionality of content provider. Content providers are supposed to provide multi-process content access from your database, but we are using it for just getting the context. So we know that there are some bad actors. How can we tame them? Well, the easiest way is to use the merge marker rule in your app's Android manifest XML file. I want to emphasize on the apps part because there's a certain priority setup to work with this. We'll talk about it. So what you need to do is that you need to add tools node remove on your tag itself. So let's take an example. In the provider that my lib init provider was adding, I could just go ahead and take the same provider signature and copy paste it in my apps Android manifest file. And then I will add the tools colon node equal to remove. And this will basically, when the merger happens, and manifest merging happens, then this provider would not be included into the last merged file. That just gets the content provider to not invoke itself. The reason we need to add it in the app is because there is a manifest merger priority. And it ranks from the library being the lowest one, main Android manifest file being the midway one, and then there's the build variant manifest file, which has the highest priority. When all of this merger happens, the final one gets created. Because we put our provider tag, the same tag within the main Android manifest.xml file, and we added the tools node remove marker on it, this one takes the precedence. This has the highest priority than the one in the library. This is why when the merger happens, the removal is taking precedence over the addition from the library manifest. This is where you have the control from the content provider not triggering itself. And if this did not exist, you would not be able to control it. All the libraries would be able to add providers and they will invoke themselves. They will initialize themselves. This is where actually AndroidX Startup library comes into view. This is part of the Android Jetpack libraries. From the base library description that you can get from the documentation, they say that it implements a straightforward performant way to initialize components at the app startup. Okay, it's pretty simple, but we'll figure out exactly what they are saying. So you can find the sources of this library on GitHub itself. It doesn't have a lot of classes. It has probably 6 classes that you need to look at, but it is worth looking at what they do. It is worth also mentioning that from what I have understood and I've looked through their code base, it looks like they took inference from the Facebook Stetho library, and they used reflection to actually initialize everything. But we'll look into that a bit. And another milestone that we need to also keep into consideration is that it became stable on October 28th. So it's like pretty recently it became stable at 1.0.0. And now it is suggested that all library developers at least should start using this versus of adding their own content provider. So what does it actually do? Well, it allows to initialize libraries without having to define a content provider on their own. I'm putting emphasis on defining without having to define a content provider on their own, because AndroidX startup library itself adds or injects one content provider. And then also, it also allows lazy initialization and define the order of initialization. So if you had to actually set this up, how would you do it? Well, the simplest is that you go into your library module, add the implementation, like the dependency itself, the startup runtime, 1.0.0. And then instead of actually creating an init provider, we're going to be creating an initializer. So this class actually comes from the startup runtime dependency itself. You create a class called mylib initializer, and which extends from initializer, and then you pass the class that you want to get back. So in this case, you want to get back an instance of the library itself, right? mylib.init class. And it has two functions. It has one called create, and it has one called dependencies. Now, create is basically the most simplest one because it provides a context. You can initialize your library in this one, and then you just return it back. And then the dependency one is actually super important because this is the one that defines that if there is any dependency, then that needs to be initialized first, and then the mylib needs to be initialized. This is where we are talking about the ordering of initialization. Considering you don't have any dependencies, you would say empty list in the dependency function. But if you do have some dependency, let's say, for example, you have my awesome lib as your new other library that you have dependency on. So we'll probably change the signature of our mylib. We'll say mylib.init, and now we are passing in my awesome lib, and that takes in a context, right? But my awesome lib will only be available if it is initialized before mylib, right? So to do that, you actually include in the dependencies, and you mention the list of and the initializer class. You can see we are mentioning the Java class is because internally this initializer class is actually going in and doing a reflection and also doing some sort of um, like invoking the init function through the initializer class. And as an added step, as I mentioned, you also need to add the provider. The provider is exactly the same. You need to add this in your library, and then you add a metadata in this one. Okay, so note that this metadata, if you had a dependency, you still just need to mention the entry point. So in our case, mylib initializer would still enable discoverability of my awesome lib initializer. So you just mentioned the first one, the dependencies are found automatically, you don't have to worry about it. But if you don't have any dependency, then also it works the same way. There's no difference in that process. Once you have added this, what happens is that your library is actually initialized in proper order. So if it has dependency, the dependency is initialized first, and then the my lib is initialized. And then you go ahead and you use the normal way as you would use it. But what if you wanted to disable the init? Why are we saying this? Because at the end of the day, Android X startup is still using a content provider trick, right? And it is going to be initializing some libraries that you probably maybe don't want to initialize. So in that sense, the trick is still the same, but you need to now do the remove on the metadata tag. So earlier you were doing it on the full provider because that's what was going in. But in this case, the way that Jetpack or AndroidX startup works is that it creates meta tags to differentiate different initializers. So now your tool node goes on to the remove, onto the meta tag itself. But say you just want to disable everything. You don't want the AndroidX to start any libraries because you want to find something, you want to debug something, and you just want to stop all the initialization process through AndroidX startup. Then your tools node marker for removal would go on to the provider itself. This is how it will look. You don't have to worry about metadata or anything. The whole provider is just gone. And this kind of works the same way as we said earlier in the content provider version. But notice that once you have disabled the auto initialization completely, now you need to initialize the libraries on your own, right? This is where we start talking about lazy initialization, as in once the app has loaded, you decide to initialize the libraries. To do that, there's an helper class called app initializer. The Jetpack, the startup library itself uses app initializer internally, but they also made it public so that you can use it. You can get the instance and initialize the component wherever you want. So you are doing this manually, you are taking care of everything. Nothing is happening automatically. And this happens when some libraries are not working as they should be, and you want to do it on your own. Then you disable them in the manifest file by putting the tools node remove, and then you initialize them by your own manually. So how good is it? Well, there are a couple of things that we already talked about, right? Like it allows to have dependency initialization in order. You also get the option of lazy initialization. Um, the important point to note here is that only one single content provider is being used. And this is where they start talking about the performance of this library. Because earlier, if there were multiple libraries, they were contributing their own content providers, and each of them was starting up, right? They're based on their blog and the benchmarking that they have done. They said that you literally save 2 milliseconds of each of these content provider, and there's only one now. So that's a huge performance boost. I have yet to see this on my own, but that's how their benchmark or whatever numbers they gave in the blog post said. It does come with link checks. So you have the Gradle app lint debug, and that will allow you to run the link checks. It will basically check if you have the provider in the manifest file or not. Did you set up the initializer properly? And super nice checks in place for you as a developer, as a library developer. The bad part though is that it still uses the content provider trick, and that's by default. It's gonna be there forever. I guess that's the whole trick with the AndroidX startup library. And another point to note is that there is no support for async initialization or multi-process initialization. These are two different things. Right now, it's basically starting up within the same process as the provider is getting initialized, and it is triggering the initialization process on the same thread itself. So that's a support that's not there yet, probably would be there in the future. And then there's a bug tracker that you can actually go to and you can find it. As of now, they don't have a lot of bugs that are open. The ones that you are seeing right now are the only ones that exist right now. I think 7 or 8 of them. And I think that is because not a lot of people are using it, or at a huge scale, it's not being used. But in that sense, most of these things are easy and probably would be fixed pretty quickly. So are the devs actually using this? That's an important question. The short answer is yes, they are. You have these libraries called What the Stack, Sentinel, Phone Emoji. You also have RetroAuth and TikTok, which are all using this initializer approach through Jetpack Startup or AndroidX Startup. And they are kind of working in a more harmonious way than they were if they were using their own content providers. So what's next? Well, based on the whole blog post that they released in July this year itself, it's been mentioned that they have these AndroidX libraries that they all need to migrate. So we already talked about Work Manager and Process Lifecycle Owner itself still don't use the Jetpack Startup, right? They use the content provider trick, and the Firebase app also does, like, it uses the content provider trick. So they have yet to migrate this to Jetpack Startup, but it also became stable recently. So the idea is that all these other libraries would also migrate to Jetpack Startup, and everyone would probably not include their own content provider at the start at the same time. And also, hopefully, more library devs will start using Jetpack Startup. That's the general idea. We would want to see more Android libraries to start using this, because adding your own content provider is not helping anyone. You get sluggish UI, you have bad startup times, and you also find all these different ways that people can misuse this, right? And mostly analytics SDKs are the ones that are doing this. So you have to find ways of removing those providers from the Android manifest file itself. All the code that I actually showed you is up on GitHub. You can go to this link. I will also share my slides. And you can just visit this GitHub repository where you will get the list of all the examples I was talking about, using a normal class constructor to init a library, normal class init function to init a library, lifecycle observer, singleton, content provider, AndroidX startup itself. And I guess that's all for my side. Thank you. And if we have any questions, I would be happy to take them. Okay, great. So I have some questions already up here. The first question is, can libraries be initialized in parallel if they are independent? Well, if you're using the same, if you're using the Jetpack Startup library itself, the idea is that you define the order and they will not be doing in parallel. As I said, it does not do async. Everything is sequential right now because there's just one content provider. So you are going to be defining your dependencies, which one gets initialized first, and then the next one, and then the next one. If it was possible to do it in an async manner, then we can start talking about parallel initialization. I hope that answers the question. The next question is, does it guarantee that my application on create is called after the initialization is completed? Hmm. If I understand the question correct, it's talking about the application class is called after the initialization is completed. Um, I would not say that is true because the my application class is actually initialized first. That's when your process is starting up, and then your components are started. So your activity, your broadcast receiver, your services would get started, right? But even before all these components get started, the provider would be started. So application on create is called before the initialization is even talked about. Okay, so the next question is there a way to tracing the initializer? I guess you could just hook into the initializer and you can put logs in there. You could put debug points and you could trace it. But there has been no, I would say, AndroidX library to provide tracing or some functionality to measure the performance. But it is possible. I believe that if you hook in enough debug points and if you put enough logs, you could potentially get the startup, the time it takes for the installation to work. Great. So the next question is, did you measure the difference in app startup time in terms of milliseconds after implementing the new startup lib? Okay, so I did measure it. And for me, I tested it with Facebook library and I was using a Firebase library. The difference in milliseconds, I would say, is not huge. But what I did see was that my application did start up faster than it did when I was doing the standard content provider based version, not using the initializer in general. So I think the millisecond probably would be in like 2 to 3 milliseconds different, but you can see it visually that those two apps reacted different. I could actually put a video on my repository or something like a GIF that shows that difference, and maybe that would be helpful for people those who come to that repository. But I do have that code. I could just definitely put it out. It's a simple sample app. You could just integrate the library and just try to initialize it. Okay. Um, and then the last one is no. I think this is more of a sentence than a question. It says no, content providers on creates are called before application on create. That's why people abuse content provider for this. I would say I haven't yet tested this, so I'm giving an answer basis on like what I think is the valid one. But if someone has already tried this out, that the applications on create is called before, sorry, the content providers on create is called before the applications on create. I guess I would learn that information, but I've definitely not tried to check which one is called before. Ideally, the application on create should be called first, but if that is not happening, I guess the answer just changes a little bit. That's probably all the questions, I guess. Great.